Good morning to one and all. My name is KIRAN Kumar. I am from Triple A section, and today my tech talk topic is electric traction. First of all, electric traction is a system that causes the propulsion of a vehicle in which the driving force or traction force is obtained from various devices such as electric motors, steam engine drives a diesel engine, and drives etc. It is known as traction system. Traction system may be broadly classified into two types. They are electric traction systems which use electrical energy and non-electrical energy traction systems which does not use electrical energy for the propulsion of vehicle. Requirements of ideal traction system. Normally, no single traction system fulfills the requirements of ideal traction system. Why? Because each traction system has its merits and suffer from its own demerits in the field of applications. And the field requirements of ideal traction system are: ideal traction system should have the capability of developing high tractive effort in order to have a rapid acceleration. Vehicle should be able to run on any route without interruption, and equipment required for traction system should be minimum with high efficiency. It must be free from smoke, ash, and dirt, etc. Regenerative braking should be possible, and braking should be in such a way to cause minimum wear on the brake shoe. And locomotive should be self-contained, and it must be capable of withstanding overloads. Mm. Interference to the communication lines should be eliminated while the locomotive running along the track. And some of the advantages and disadvantages of electric traction are: electric traction system has many advantages compared to non-electronic electrical traction systems. The following are the advantages of electric traction. Electric traction system is more clean and easy to handle. No need of storage of coal and water in turn reduces the maintenance cost as well as the savings of high grade coal. Electric energy drawn from the supply distribution system is sufficient to maintain the common necessities of locomotives such as fans and lights. I think therefore there is no need of providing additional generators. The maintenance and running costs are comparatively low. The speed control of the electric motor is easy when compared to others, and regenerative braking is possible so that the energy can be fed back to the supply system during the braking period. In the electric traction system, in addition to the mechanical braking, electric braking can also be used that reduces the wear on the brake shoes, wheels, etc. Electrically opened, not operated vehicles can withstand for overloads. The system is capable for drawing more energy from the system. In addition to the above advantages, the electric traction system suffered from the following drawbacks. I mean disadvantages. Addition to the above advantages, the electric traction system suffers from the following drawbacks. Electric traction system involves high erection cost of power system. Interference causes to the communication lines due to the overhead distribution networks. The failure of power supply brings whole traction system to stand still. In an electric traction system, the electrically operated vehicles have to move only on electrified routes. Additional equipment should be needed for the provision of regenerative braking, and it will increase the overall cost of installation. Review of existing and the another topic is and the same in electric traction system, the review of existing electric traction system in India. In olden days, first traction system was introduced by Britain in 1890. Electrification system was employed for the first traction vehicle. This traction system was introduced in India in the year 1925, and the first traction system employed in India was from and the traction system in India in the year 1925, and the first traction system employed in India was from Bombay BT to Igatpuri and Pune with the 1500 volts DC supply. This DC supply can be obtained for traction for substations equipped with rotary converters. Development in the rectifiers leads to the replacement of rotary converters by mercury arc rectifiers. But nowadays, further development in the technology of semiconductors, these mercury arc values are replaced by solid state semiconductor devices due to fast tracking system, and it was introduced on 3000 watts DC supply. Further development in the research on traction system by French International Railways was suggested that based on relative merits and demerits, it is advantageous to prefer to AC rather than both financially and operationally. Thus Indian Railways was introduced on 52 kV to 50 Hz single phase AC system in 1957. The system of track electrification leads to the reduction of cost of overhead locomotive equipment, etc. Various systems employed for track electrification are shown in table. System of traction system is normally classified into two types based on the type of energy given as input to drive the system, and they are non-electric traction system, electric traction system, self-contained locomotives. Self-contained locomotives are some of the examples of self-contained locomotives are steam electric drives, diesel electric drives. They have some advantages also. Then coming to non-electric traction system develops the necessary propelling torque which do not involve the use of electrical energy at any stage to drive the traction vehicle, known as electric traction system. For example, a direct steam engine drive and direct internal combustion engine drive. Electric traction system develops the necessary propelling torque which involves the use of electrical energy at any stage to drive the traction vehicles, known as electric traction system. Based on the type of source used to feed electrical supply for traction system, electric traction may be classified into two types: self-contained locomotives, electrical fed locomotives from distribution network. Coming to self-contained locomotives, in this step the locomotives or vehicles themselves have a capability of generating electrical energy for traction purpose. Example for such type of locomotives, as I mentioned earlier. And advantages of diesel electric trains and steam electric drives are as these are no overhead distribution system, initial cost is very low, easy speed control is possible, and power loss in speed control is very low. Time taken to bring the locomotive into service is less. In the system, high acceleration and braking reduction can be obtained compared to steam locomotives, and the overall efficiency is high compared to steam locomotives. And disadvantages, the overloading capacity of the diesel engine is less, the running and maintenance costs are high, and the regenerative braking cannot be employed for the diesel engine drives. And uh, there are traction motors also. No single motor can have all the electrical opening features required for traction. In earlier days, a DC motor is suited for traction because of the high starting torque and having the capability of handling overloads. And there are the squirrel gauge induction motor has several advantages over the DC motors. The robust construction, highly reliable, low maintenance or low cost, and high efficiency. And synchronous motor features lies in between the squirrel gauge induction motor and the DC motor. The main advantages of synchronous motor over the squirrel gauge induction motor are: the synchronous motor can be operated at leading factor by varying the field excitation. Load commutated thyristor inverter is used in synchronous motor as compared to forced communication thyristor inverter in squirrel gauge induction motors. Even though such forward communication reduces the weight and volume of induction motor, the synchronous motor is less expensive. And uh, these are the topics I need to cover. Mm. Electric braking, I need to explain electric braking also. Electric braking can be applied to the traction vehicle by any one of the following methods, namely plugging, rheostatic braking, regenerative braking. Plugging is nothing but it is necessary to disconnect the motor from the supply as soon as system comes to rest. The main disadvantages of method is that the kinetic energy of the rotating parts of the motor is wasted, and an additional amount of energy from the supply is required to develop the torque in reverse direction. The diagram shows the plugging of DC shunt motor as you observed it, and this diagram is a DC series motor plugging. The derivation is shown below. And thank you for giving this golden opportunity.